Hi, hello, and welcome to this video, whereby I'll be taking you through a walkthrough of a three-tier architecture, how to deploy resources in a three-tier architecture. For an example like this for a client, where you have three layers: the web layer, the app layer, and the data layer. Or the web layer can also be called a presentation layer. So for this, we'll be having our instances running in a web layer, running Apache web server. Then you can have, for instance, an app layer running your application resources. And then for a data layer, you can have a database, RDS instances running Amazon Aurora, MySQL instances. Also, you can have our elastic load balancers at both the web and the application layer to distribute traffic among the targets. The web elastic load balancer will be internet facing and will distribute traffic to our instances in our web layer. And for our app layer, we'll have an internal elastic load balancer that will distribute traffic among our app instances. We'll also have our internet gateway attached to our VPC, and then that will be will allow our public subnets to access the internet, of course, alongside a route table entry, having a route to the internet gateway. And then also, finally, we can add maybe CloudFront for further security and also to help the performance of our web instances or our web server. So before I start for our video, an introduction about myself. I'm Kiprotich, an AWS Certified Solutions Architect Associate, and also an AWS Community Builder under the data category. So maybe you can reach out if you have any questions and we can connect. Okay, so moving on. Um, let's go to our AWS console. And the first thing we need to do is to create our VPC. So you can go over to the VPC. Just a minute for it to load. And then the first thing we'll do is to create our VPC. So you can go over and click create VPC. You can just use the default VPC only, but you can also use the VPC and more because it offers more features and you can clearly see the route tables and everything over there. It enables you, it makes it easier to create, but we'll just go with the default one. And I think an advantage of this is that you can be able to customize everything over here just with a nice user interface. And you can specify NAT gateways, VPC endpoints. It just creates everything so easily for you. So, but for now, I'll just go on and show you how to create these things just one by one slowly. But this is an approach you can take. So let's just go to the old method, but this is an easy way to do if you know what you're doing. So for our name tag, you can use the name CloudForce VPC. Okay. Then for our CIDR mask, for range, you can use 10.0.0/16. Moving on and leave the rest maybe as the default for now. And for our VPC, you can go on and edit some VPC settings. We need to enable DNS resolution, DNS hostname, so that will help with resolution and for the host names for our DNS settings. Also, we know that for our VPC, we need to attach an internet gateway with that. Whenever you create a new VPC, it doesn't come with an internet gateway. This one is attached to the default VPC in my account. So I can go on and click create. For our name tag, maybe I can use CloudForce VPC and create. Then you can go on and attach it. You can click over here or go over here and add actions. So you can go on and attach it to the VPC that we just created, starting with 02. This is the CloudForce VPC, and attach it. That should be okay. And then moving on, you see that we need to have 6 subnets over here in our architecture. 2 of them being public and 4 private ones, and 3 in each AZ, as you can see. So we can go on and create our subnets. Create our subnets. For VPC, we select the 02 VPC, but this figure will change depending with your video or in your lab. But just take note of that so that can help you to kind of just confirm that. For a subnet, you can have a web subnet, which is public. Maybe I can call this one because you have one in each AZ. You can use 1A, the CIDR max. I can use 10.0.0/24. Okay. And then you can see that I am using the numbering notation such that we have the ones will be the one in the 1A region AZ, and then the twos will be the ones in the 1B AZ. So moving on, you can create another subnet. Maybe I can call this the web public to subnet. The AZ should be the 1B AZ 10.0.1.0/24 cider block. Moving on, we need to create our subnets for our app layer, and they should be private. Private one, the 1A AZ. And then maybe for these ones, I can use the tens, maybe 10.0/24. Then I can add a new subnet, app private two. That should be in the 1B AZ. And I can use 10.0.11.0/24. Moving on, I can go now to our data layer or DB subnets. So maybe I can call this maybe DB private 1, and this will reside in our 1A AZ. Maybe I can use the 10.0.20.0/24. Then the final one should be our DB private 2. This should reside in the 1B AZ. 10.0.21.0/24. Yes, that should be okay for now. And then you can create them. This should take just a short while to create, and it should be done. So you can see that we have created the subnets. Just clear these, and yeah, these are our subnets. Maybe I can filter with VPC, choose the 02 VPC. So we see we have these subnets. Let me just a moment. Yeah. So you have our app privates, the DB privates, and the web public subnets. But just by naming these doesn't mean that the subnets are public. For the subnets to be public, you have to have them associated with the route table, and the route table should have an entry to the internet gateway. So we can go on and create a new route table. I call it the public route table for the VPC. It is the CloudForce VPC that should create it. After creating it, we should edit a route and add the route to all sources or everywhere. And then our target should be the internet gateway. And we choose our CloudForce VPC internet gateway. Then we save. So now any subnet that will be associated with this route table should be able to access the internet or should be a public subnet. So you can go on and edit subnet associations, then associated with the web public subnets. Just something to note is that the other subnets will just remain in the default route table, and with that, that will mean they will only have routes or be able to communicate just locally. It will only have the local route, as we can see over here. Just a moment. This is the default in our VPC, and the other subnets are associated over here because they don't have any explicit associations. So you can just leave them as they are for now. Moving on to define security in our architecture, in our network. We can use security groups. You can also use network ACLs at the subnet layer or level, but you'll be able to use security group to define just specific permissions. So you can be able to create them, and I'll be explaining them as we go. The first one that you can create should be the web ELB security group. For this will allow HTTP traffic from the internet, basically, or from all sources. And then for the VPC, just begin with this to choose the CloudForce VPC. Don't leave it as the default because I've created a new VPC. But if you are working with your default VPC, you can leave it as this. And then we have to add a new rule. So we'll have a rule allowing HTTP traffic Then for the source, we can just leave it as NUI IPv4, all sources. That should be our web ELB security group. We can go back and create a new one. Once we deploy our instances or our resources, you'll be able to see how they integrate better. For now, let's just create them. I'll just be explaining what they will be doing. For our web security group, this will allow HTTP traffic from the web ELB. Then we change the VPC. How can we enable this? We add a rule allowing traffic, HTTP traffic, and for the source, you can type in SG. Then you can be able to see, you can select the web ELB security group. So this will mean that only traffic from the web ELB will be able to reach our web instances. So we can save that. We can go on and create another security group. For this one, maybe I can call it the app ELB security group. For this will allow HTTP traffic from the web instances. The VPC again. Then you can add an inbound rule allowing HTTP traffic, and from the source now, it will be the web security group. Then I can create that. Moving on, I can create other security group as well. Now for the app instances, so I can call it app SG. This will allow HTTP traffic from the app ELB. Then change the VPC to be the right one for our scenario. Then you can add a rule allowing HTTP. Type in SG, and then we specify the app ELB SG. We can create that. And then finally, we can create a security group for our database instances. You can create them while creating the database or in another section, but I prefer doing all the security groups because as you can see, we have our architecture over here and you can be able to create them fast as we know how everything will be working for this scenario. So for this, it is the DBSG. Let's say now for our app instances need to access our database running MySQL. So this will allow MySQL traffic from app instances in the VPC again. Then you can add a rule allowing HTTP traffic, and then our source will be SG. And under SG, I'll specify the app SG. Sorry, this is for MySQL, so this should be MySQL. With that, so for this, you can see that we already have our security groups, all our security groups created. Then we'll be using them now with time as we go by. Now, moving on, since we have our security groups, we now need to start creating our resources in our VPC. We have our security groups, but now we need to create our elastic load balancers, auto scaling groups for our instances in the web and the app layer, this ELB, and then also the RDS. The first thing I can do for this walkthrough is maybe I can start with RDS since that maybe takes some time to load up, and by the time we'll be done, this should be done fully. So the first thing I can do is to create RDS. So if I can open RDS in a new tab, and then we need to create our RDS instances over there. Just a moment as this loads. And the first thing that you can do, since we are very specific that we want our RDS database instances to be launched in these two AZs, the first thing that we can do is we can create a subnet group. And this is the one we'll specify now when creating our instances. So just a moment. Moving on. So for the subnet group, you can see that it allows alphanumeric characters, spaces, and hyphens. So maybe I can call it the DB subnet group. And then just I can call this DB subnet group under description because you need to specify a description. For our VPC, we select our CloudForce VPC. For our AZs, we specify the 1A and the 1B AZ. And then for our subnets, we have to specify the subnets that we created for our that we want to use for our databases. For our case, it was the 20s. Maybe I can just go over here and let you confirm that. You can see that our DB subnets are in the 20 and the 21. So maybe I can go over and select the 21 and the 20. Those are the two subnets that I have selected. Then I can create this subnet group. Alright. So that should be created. Moving on, I can now go on and create our database. So for our database, I'll be able to select create database. Then I can just use the standard create. I can leave it as Aurora MySQL since I'm using MySQL for my scenario. I can use maybe choose the dev or the test template, and then can leave this as default. Then I can maybe auto generate a password, but if you wanted, you can specify a particular password. You can also store the passwords in Secrets Manager if you want auto generating. But moving on, you can leave these as they are, but you have to specify multi-AZ deployment so that you have like one writer instance and a reader node in a different AZ. And this is recommended for scaled availability. And it provides fast failover and high availability. So we can specify that. For connectivity, I can leave it as that, and that these are the same. For the VPC, make sure to change this to the new VPC or the VPC that you are working on. Then for the subnet group, which is the DB subnet group, remember this is the one that I have just created. Public access is no. For the security group, I'll cancel this and select the DBSG that I created earlier on. And I'd already specified the ones, what is permitted. That is MySQL from the app instances to the RDS instances. Then moving on, you can create an RDS proxy if you need to. For the additional, you can leave it as the default port. You can leave these as they are. You can leave them as they are. Just checking on these. This enable and enhance monitoring. You can leave it as here as it is, and you can specify maybe this if you need to. But for now, this is just to demonstrate the creation of the database. I can leave it as it is, and just click on create database. So this should go on and create our database. It should take a while, but eventually we'll have our database. You are given options to maybe create an Elasticache cluster or an RDS proxy. If your use case needs this, you can read it up and create it if need be. So I'll just give this a while. It normally takes a while to load up. So just leave this tab open and keep on refreshing after a while. But maybe I can just give it like 10 minutes to create or some while. But once we will be done with the rest, we'll create it. So moving on, the next thing we need to go is to EC2, the EC2 management console. So you see that we need to create an ELB, an auto scaling group, and the ELB as well over here, another auto scaling group. What we can do to create this under EC2, just a moment. The first thing that we can do is we need a launch template or a launch configuration, because we need like a skeleton or a skeleton or what our auto scaling group will be using to create our instances, a template for it. So the first thing that maybe we can do is to create a launch template. Launch templates are preferred over launch configurations because, sorry for the background noise, launch templates are preferred over launch configurations because they normally have enable versioning. So maybe I can delete these. These are remnants from other projects that I was doing. Maybe I can just delete them to, to avoid some confusion in the lab. But you can enable maybe just use a naming scheme that will allow you to sorry, just use a new good naming scheme so that you can't confuse them. But for the here, I can just clear them so I can create a launch template. So we will be needing two launch templates, one for the web layer and one for the app layer. For the web layer, we'll differ in that it will be public, and maybe we should be able to, for the web layer, to install an Apache server using its user data. So moving on, maybe I can call this the web template. Then maybe I can just call this a web server for the web layer. Then you can ask to provide guidance to help us set a template that we can use with an EC2 auto scaling. Then moving on, you can specify our AMI. Choose one that fits your needs. For this scenario, I can just keep the Amazon Linux and just use Amazon Linux 2023. And for the instance type, I can just use the one that is under free tier, the T2 Micro. This also is under free tier, so if you are doing this as demo, this can help a lot. For the KPI, if you don't have one, you can create. If you have one, you can specify over here. Then for the subnet, we won't be specifying these. We'll be specifying these later on while we'll be creating the auto scaling group. Then for the security group, we can select our security group that we had created. This is for the web instances, so we'll choose the web SG. Then under advanced network configuration, maybe you can add a network interface, and then we can maybe allow it to auto assign public IP over here. And then moving on, I think you can just leave the volumes as it is. And the advanced details for this one, you can maybe enable resource-based IPv4 DNS requests. And then also for under user data, you can specify a script or something that you want to run in your instances once they run. So maybe I can use that and specify as it is. So this is the user data that will be running. So this will just switch us to the root user, and then it will update and then install HTTP or Apache. Then you can start it. And what this will do, it will under the index.html, it will write or input hello world from, and then it will have the host name of the instance. So once we'll be able to visit the website later, you'll be able to see how this plays out. So just to review over here, this is okay, the T2 micro, then you have specified the right security group. Then we can create the launch template. And then we can go on and create another launch template for our app layer. So for this, I can just call it the app template. And we can just call this an app server. Provide guidance for auto scaling. For here, I can just do it as before. Specify the Amazon Linux or whichever is your preference or that you need. For the instances, I can just use T2 micro, the instance type. Key pair, I can just use the same or create a new one. Under security group, we should be able to specify the app security group. For the network configuration, maybe I can just leave it as it is since I don't need public IPs. Yeah, that can work. And then I think the rest I can just leave it. I'm not using user data for this one. Something that has just come to mind under the VPC for our subnets, our public subnets, there's some edits that you can do to maybe help everything to work well. So maybe I can go back to your VPC and go back to subnets. And then for your public subnets, the web public one and web public two, you can select it and then you can edit the subnet settings. Make sure to enable auto assign public IPv4 addresses. This will help. And also the DNS records. So I've done that for the web public one. Then I can go also to web public 2 and do the same. So this is something that I didn't do earlier under the VPC settings, but we're still on track. Yeah, so I think that should be okay. So moving on. So we have just created, let me just open this tab. We have just created a launch template. But our aim is to be able to, in our architecture over here, our aim is to be able to have an ELB distributing our traffic to our targets. And then the targets will be able to be created by the auto scaling group. So the auto scaling groups will be using the templates that we have created, the web template and the app template. What I can go on and do next, because we need to create our ELBs first. We see our database is still, I think it's over there, it's still working on it. So we can go on and go to load balancing and select the target groups. So we need two separate target groups, one for the web layer and one for the app layer. So you can go on and create a target group. Our targets should be instances in this case, but you can go over the others if need be for your scenario. But for this one, it should be the instances. I can call this the web targets. We are using the port 80 HTTP protocol, and then the CloudForce VPC. Can leave the protocol version as that. For the health checks, that's the default path. If you want to maybe change the checks over here, you can be able to modify that. But I can click on next. And then for this page, I want to be registering targets because I'll be able to attach these to an ELB and then also to an auto scaling group. The auto scaling group is the one that will be able to register targets once it creates them. So I won't be registering targets manually for now. So I can create that. And then I can also create another web target group for app instances. So I leave it as instances. Call this the app targets. Give this as port 80. Change the VPC. And then can just this is the similar to the other one. I won't also be registering any targets for this scenario. So then just create it. Once this is done, I should now be able to create the application load balancers comfortably. So I can go over to load balancers, create load balancer. Over here, I can specify the application load balancer. For the load balancer name, maybe I can call this the web ELB. And since this is the one that is internet facing over here, I'll leave it as internet facing IPv4. For the VPC, I select the CloudForce VPC. And then under mappings, just a moment for it to load, we'll be able to choose the US East 1A. And then for the subnet, I'll choose the web public one. And then East 1B, you can be able to select the web public 2. And then for the security groups, remember that we had created a security group for our web ELB. So I can be able to select the web ELB security group. For the listeners, I'll just leave it as port 80. Then for our target group, it should be the web targets. And then that should be done. Just a moment. Yeah, that should be okay. Then these are summary. It is the internet facing, the web ELB security group. And then we have our web public 1 and web public 2 mappings. Then we have our targets over here as the web targets. So we can create this load balancer. And then just maybe view it. And then I can go on and create another load balancer. Now for the app targets, go into application load balancer name, can call this the app ELB. The app ELB. And then now for this is an internal. Since it is not internet facing, it should be internal. Since it is routing requests from clients to targets using private IP addresses or internally over here locally. So have it as internal. For the network mapping, select our VPC. And then for the mappings, we should be able to select our two AZs, and then as we select our app private one, since this is routing traffic in the app layer. And then for the 1B, you select the app private too. For our security group, we select the app ELB security group. And then for the target groups, we select the app targets. So this should be okay. And then we can go on and verify this. It is internal, the app ELB security group. And then we have our desired subnets and the right target group. So I can go and create the load balancer. So the final piece in our puzzle over here now is the auto scaling group over here, our auto scaling group, that we should be able to right size our instances based on the parameters that we set and in the right layer. So you can go over to the auto scaling groups over here. And then maybe the first thing that I can create is the web auto scaling group. So maybe I can call this the web SG that will scale our web instances. For the launch template, I will specify the web template. Then I can leave it as the default version and the rest as the same. I can click on next. For the VPC, I'll specify our CloudForce VPC. And for the subnets, remember to specify the subnets where you want the instances to be placed. So I want our instances to be in the web public one and the web public two. These two subnets. So these are the ones I've specified. Then I can leave the instance types requirements as specified in the web template. Go to next. Then for the load balancer, you can attach to an existing load balancer since we have created one. Then I can choose our web ELB. Then I can leave this as no VPC lattice service. You can be able to turn on ELB health checks since this is recommended and it will help you to perform checks also using the ELB alongside the EC2 health checks. I can leave the grace period as the default 300. Then I can leave this as it is. Moving on, for the desired capacity, minimum capacity, and maximum capacity, maybe I can have a maximum capacity as maybe 3, and for our minimum as 1, and then desired capacity as 2. What this means is, once our instances are created, first of all, it will create 2 instances. But after a while, after verifying whether um, the policy that we have used for scaling, whether we need more instances, it will scale up to 3. But if maybe the demand isn't as much, it will scale down to just 1 instance. Maybe I can leave this as this to demonstrate that. And then for our scaling policy, I can use our target tracking scaling policy. And then you can say that we want to target the metric of average CPU utilization. You can be able to change that if you need to. Let's say to change if maybe if it exceeds 60, it should be able to scale up or down. Then you can move on. So you can say our instances maybe need 100 seconds to warm up before including in the metric. Then we can go on to the next section, to notifications if you need to, and tags if you need to. Can move on. And this is just a summary of this, just to cross-check. We're using the web template, our network, we're in the right VPC and the right subnets, the right load balancer, and the correct health checks, the grace period, and then the right group size that we want for our need. This is a scaling policy, and I think that is correct. You can be able to create it. And then finally, you can be able to create another auto scaling group for our app layer. This should be similar to the previous one, so I'll just go on and you can follow through. So it is the app ASG. We choose our app template, move on and create next. For our VPC, select the right VPC, and then for our subnets, make sure to select the right one. So these are the app instances, so they should be in the app private subnets. then that should be correct. Click on next. Then maybe I can use attach to an existing load balancer. And then I choose the app ELB. Then I can turn on elastic load balancing health checks, and maybe just give it the same 100 grace period. Click on next. And then this one, maybe I can, for this, maybe I can say that I desire maybe just one instance minimum and desired just two for the maximum. So we can go on for the target tracking policy, can use the same, specify these, that should be okay. Click on next, 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 just to verify the right template, the right VPC and the right subnets, the right load balancer, and the right group size that you need, the right scaling policy. So we can be able to create this auto scaling group. So basically what we have done is up to this point. So what I can do to verify what I have done, you can go to EC2 and then you can check on the instances. We can see that already we have two instances running, and these were created by our auto scaling group, the web auto scaling group. To be able to see that well, you can go to auto scaling groups and you can see that this one, the web ASG, we already have the instances. Maybe you can go to instance management and you can see that you already have two healthy instances running. So that is a good sign. Going back to our auto scaling group, to the app ASG, we see that we already have one instance running, and that is a nice view. We can go to our target groups and verify the same. So maybe moving on, maybe we can go to our web targets, and we see that we have two targets and both of them are healthy and they have been registered. So what I can do to test connectivity to our web instances and to check if load balancing is really happening, for our web ELB, we can go on and check, get the DNS name. We can open this up in a new tab and see the response we get. So we see we are getting a response from one EC2 instance. Refresh it, still the same. Refresh it. We're getting from another instance with the 223, and the previous one was the 1.52. So maybe even if you go back to our auto scaling groups and check our web auto scaling group, we should be able to see that these are the instances that have been created. Maybe let me just, if you click on this instance, you can be able to see that this is the 223 instance. This one, 10.0.0.223. This is the instance. And then also if you check on the other instance, just a moment. But it is the other instance that was created by the auto scaling group. So this seems to be taking long. Maybe I can just go to instances and just check on them. This is the one ending with 399 and this is 7AB. So 399 and 7AB, and we can be able to see we can't be able to see the private IPs, but clicking on the 7AB, this is the .1.52, and then clicking on the 399, this is the .0.0.223. So you can be able to see that you can now be able to access our instances running in our web server through the web ELB, and that is a nice thing that our deployment has worked successfully. Checking on our database, I am getting an error. Let me just refresh and see. I think by now they should be created. So maybe I can just go to our databases. Nice. So I think it is working well, and you can be able to see that we have two database instances, one in the 1A and one in the 1B region, AZ, and you can be able to see one is the writer and one is the reader. If maybe you wanted our reader instance to be in the 1B and the writer in the 1A, basically to flip these in the different AZs, we can be able to select these and to fail over the database. So that is it is nice to test that. So this should take a while for them to switch the reader and the writer instances. So you can just give that some time and let it work. So these are set up right now. It is working. You can be able to access our instances through the internet gateway. But what if you wanted to utilize CloudFront so that you can be able to access your instances from via CloudFront, and you don't want your load balancer to maybe to overwork it. So maybe you want to only allow traffic to go to your CloudFront, and then from CloudFront to go to your internet gateway. If anyone tries to go to your ELB directly over bypassing your CloudFront, that should not work. So that should be the next and final thing that you can do in this lab is to enable CloudFront distribution and to disallow traffic to reach the ELB directly if someone had bypassed the ELB, the CloudFront distribution. So to do this, you can go on and create a CloudFront distribution first. So just to check up on our instances, you can see that they are running right now. So that should be working and it should work with time. So let's move on and go over to CloudFront. We can create a CloudFront distribution. For the origin domain, we have to select our web ELB. For the path, we'll just leave it as default. For the name, I can just leave it as that. But I can enter a name of this origin, but let me just leave it as just the name of the web ELB. And then, just a moment. So we're creating an ELB, and then moving on, we can be able to add a custom header. And this is the one that we will be using later on. So you can use HTTP, and then you can specify our custom header to be under HTTP only. So under custom header, you can specify this. For the header name, maybe I can just call this custom header. Then for the value, just for this example, maybe I can just use some values of pi, so 3.141592. It should be 3 point, but you can use any. But just take note of whatever value that you have used, as we'll be using this in our web ACL, our WAF ACL. And then you can just leave the rest as they are. That's the rest as it is. Doesn't really matter now. But if you had maybe for the cache policy, maybe I can just caching disabled or something. But this depends. But this is the most important part for you to be able to restrict traffic to your instances to just go through the CloudFront, not via the ELB. We should be able to add a custom header, and then this is the one we'll specify in our web ACL to let it our WAF ACL such that it should be able to allow traffic that has this custom header to reach your web ELB. We'll be able to demonstrate that in a few. Moving on, you can create it. So this should take a while to fully deploy, but in the meantime I can go over to WAF and Shield. Just a moment for it to load. Just checking up on our databases. You can see that it has successfully failed over. The writer instance is now the 1A, while previously the writer instance was the 1B. So that has worked correctly. So to WAF, you can be able to create a web ACL, and then for the name, I can just call it as custom header ACL, since it deals with the custom header. Leave the description. For I can just leave the metric name as the same. And then now for the resource type, I'll be using other regional resources like the ALB. So I should be able to select the region, and then under here, you should be able to add AWS resources. So the AWS resource to add is the application load balancer, and then the web ELB. Make sure to click add. That should be correct. Then click on next. So over here is where now we have to specify our rules for our ACL. So the first thing that we can do, just a moment, you can click on add rules, and then add my own rules, and then you can use the rule builder. And then for the rule, maybe I can just use the custom header as the name of the rule. And then it should be a regular rule, but it can also be used to rate-based rules in some scenarios. And then you can say if it doesn't match the statement. And then what is the statement that we are choosing? You can choose the single header, since that is the one we have created. And then over here, the match, the header field name, you can enter the custom header that we had specified earlier on. Then it should be able to match type exactly. And then the strings to match, it should be 3.141592. Remember, it is the one that we had specified earlier on. If you had used a different value for the custom header and the string, you should be able to specify that. Then no text transformation. And then what it should do, it should block. So let me just add it and then explain. So what I have done is I have added a rule that says if any request comes and sorry, just a moment, to edit, but the name doesn't really matter, but I can edit it. The name should be maybe custom header, and save that. Yeah. So let's say if a request comes to your and hits your WAF, if the custom header doesn't match the values that we have specified, it will be blocked. Otherwise, it will be allowed. So the only traffic that will come with a custom header is the traffic via the CloudFront distribution. So any other traffic that will come directly won't have that custom header value. So you should be careful to select a unique custom header value, and you should also be able to rotate them with time if you need to for added security. So I can be able to specify that, and then I can click on next. And then the priority, just leave it as the default. Then it will just, the metric name is that for the CloudWatch metrics. Then you can leave it as that. Then you can go on and review. So I've left the default as allow. So what this means is if anything is not dropped over here, that means if it comes with the custom header, it will be allowed. Then we can create the web ACL. So just a moment for that to create. To check up on our CloudFront distribution, let me refresh this and see if it has successfully deployed. Oh, it's still deploying. So maybe just give it a short while to see. Let me give it a minute.